Hello. Hello, everyone. Jump scare. I'm back. I'm here. How are we all doing today? We good? Got exams for next 3 weeks. I was at mock season. And a lot of people probably finished their mocks recently, but hello. Hello. Oh, there's words on the screen. Okay. Well, I guess all your messages are on the screen now. That's fun, isn't it? I don't think I did that. Did I? I don't know. Oh, well. How you all doing today? You all doing good? Got green tea here. I don't know why I've been really into green tea lately. I think I had one tea bag like the other day when I went to my friend's house because she had some. And then ever since, it's just been I literally bought 3 packs of tea today. I've just been obsessed. And I don't think I've ever had green tea before. And then all of a sudden, it's just green tea essentials. It's got strawberry, aloe vera. It's got lots of stuff in it. It's lovely. Been very shocked. I didn't think I'd like green tea, but here we are. Good. Should Brazil? Oh, yeah. Well, that's the World Cup. I haven't been keeping up with the World Cup. I don't think I've literally ever watched a game of football. Not once in my entire life have I watched a game of football. I'm having a good night. I think. But yeah, I'm having a good night. I just did taught us some probability. That was fun. Now I'm ready to do some straight line graphs and graphical inequalities. How fun. I've got a new ring light. Hopefully it's nice and bright. It's cost me many pounds, so hopefully it's good. It's like one of the ones that all the streamers use. It's called the key light, the Elgato key light. So yeah, hopefully it's nice and bright today. Brighter than normal. Everyone I've spoken to can't tell a difference. Maybe you guys can tell a difference. I don't know. Maybe it's a bit brighter today because it is like pitch black outside. Like I can't see anything out my window. My window's like literally just in front of my computer. Can't see a single thing. It's pitch black outside. How was TikTok famous? Well, I don't know about that. My TikToks, I don't make TikToks myself. I made a couple for my tutor, but they all like suck. So they don't get any views. I don't know why they asked me to make them. They never get any views or anything. But I mean, hey, I always make my TikToks for them. Then I mean, I've got the equipment now, I guess, haven't I? I think it's just obviously I charge relatively quite a lot, I think, for tuition. I won't tell you how much because I don't want to start arguments in the chat. But I think I'm quite a relatively good tutor, so I think I should have good equipment. You know, invest in my career a little bit. You know, so yeah, there we are. I'm gonna be YouTube live stream famous very soon, I guess. Is finding tangent partial line graphs? No, it's not, unfortunately. Because that's like grade 9 kind of stuff. It comes up a lot. But it's always the same. It's more a case of perpendicular lines rather than straight lines. Because tangents to a curve, a tangent to a circle is normally, isn't it? Where you got like a circle and then a tangent to it, and you find the gradient of the radius, and then you negative reciprocate it to find the gradient of the tangent. That's more like perpendicular lines. We will do finding gradients today, but more gradients of like lines rather than gradients between 2 coordinates, which is more like what that is, like between like the origin and whatever point the tangent meets at. So fortunately not, but we'll be doing adjacent things, sort of. You know, we'll be doing like gradients and stuff, which I guess is kind of part of the topic, but not like in the same context. You know, a bit different. It's quite cold now, actually, but I made it at like 3:45, so it's a bit cold now, but alas. Cool. I think we'll maybe give it a couple more minutes and we'll get started. We have a couple more people to show up and then we'll get started. Cool. How's everyone's mocks been? I know everyone had mocks recently. Everyone that I'm teaching getting their results back, like about now. How did everyone do, I should say, proper English, in their mocks, if they did them recently and not in January, obviously. And you haven't done them yet. But how did everyone do in the mocks that people have just sat? If you sat them at all. If anyone's here. There's just recently done mocks. How did we all do? Most of them, that's okay. Most of them alright. Silly mistakes. Yeah, that's part of the course, isn't it, I think. I think it's good that you're making silly mistakes now and can spot them rather than making them later. Right? Because if you make them in your real exams, then they're not coming back from that, right? You make them in your real exam, you either resit it or you just walk away, you know, throw your hands up and walk away, right? So it's good that we're seeing them now, because I used to make loads of silly mistakes, particularly with like negative numbers. I hate negative numbers. I still make mistakes with them like constantly, but the more papers you do, the more you'll see, okay, I make mistakes here, let me double check here, right? Because you see it when you first do, like when I do a question with negatives now, I'll be like, oh, that's a negative. I don't like those. Let me make sure I'm paying extra special care and attention, right? You can still make silly errors. I do it all the time. I'll probably do it once a day later on, right? But then at least you'll know exactly where you go wrong all the time, and then you can like kind of better prepare for it. Also, then you'll know like when you go back at the end of papers as well, you can do like more targeted searches, if that makes sense. And you should always go back at the end of a paper and go look through like for significant figures, make sure you rounded it all correctly, and you should go back and look through for things like the word estimate in case you missed it, and things like the word like units in like physics and chemistry and such. Go back and do like a sweep through for those. You can also add like negatives to it. If you see a negative in your question, make sure you've handled it correctly. If you're doing like a more targeted search, be more is to catch your mistakes rather than just like kind of hoping for the best where you're going through it all in one go at the end. You're very unlikely to catch anything if you go through it all in one go at the end. So doing more targeted searches for specific things will work out a lot better. Hello, Lyrics Blue. All my regulars coming in at this point. So we'll get ready. How have you been, Lyrics Blue? How have you been? So yeah, do we have any questions before we get started? If not, we'll get started like now. But do we have any questions before we start? Oh, anything. I'm open to anything. Do we have any questions before we get started? I'll take one last sip of my cold tea. I have a mock tomorrow, so revising and forgot this was lesson was happening. Oh, that's okay. I mean, you made it. Is it a maths mock? Maybe this will be helpful. I don't know. What's the mock in? Anything exciting? Yeah, I'm good. Thank you. I'm very good. I got a new obsession for green tea, as I was saying. Got the new, I don't know what it is, Twinings called Glow. Got strawberries in it. It's quite nice. So yeah, hopefully it's unlocking something useful. English language. I can't help you much with that. I used to be relatively good at English, but I've since lost all knowledge I once had for English. I used to get full marks on my coursework. I remember getting full marks on one of my Macbeth essays, the method on like Lady Macbeth. Got full marks on that. I was quite proud of that. I still remember that to this day. But anyway, let us switch screens and make a start on some maths. That sounds good. Where are we? Show time. Here we are. Fun times. Can we see the PowerPoints? Can it be seen? I don't know why my image box is so wide. I tried to change it earlier, but I could not figure it out. I don't know why it's so big. I think I can fix it for next week. I don't think it's always been like this, but alas, can we see the PowerPoints? Is it visible to our eyes? And all that, hopefully. If no one's complaining, I'm assuming that is true. Cool. So, first thing we're going to do, yeah, thank you. First thing we're going to do is just figuring out gradients and equations of lines. So, can anyone tell me what is the standard equation for a straight line graph? What is the standard equation for any straight line graph that's like slanted? It's not like horizontal or vertical. What is the standard straight line equation for those that are horizontal? Perfect. Absolutely right. Perfect. Y, where's my pen? Y equals mx plus c. Perfect. What does m refer to? What does c refer to? What do those things mean? What does m mean? And what does c mean? Why are they there? Who are they representing? Perfect, absolutely right. So m is always the gradient. So I've got a couple of students that make the error that mx is the gradient, and be careful, it is not. Only m is the gradient. X not associated with the gradient. X is just there. He's just chilling, right? It's not part of the gradient. The gradient is just the number in front, whatever that number is. If it has a negative sign, it's also the negative sign, if one happens to be one there. If it's a fraction, it's the full fraction, but just whatever happens to be in front of x is the gradient. As long as it's in this form exactly. Y is on its own, not multiplied by anything or anything like that. And then we got c, which is, you guys are absolutely right, the y-intercept. And what does that mean? For those that don't know, what is an intercept? What does that mean? Y-intercept. What is that? What does that mean? A y-intercept. What are we talking about there? Y-intercept. Crosses the y-axis. Perfect. Absolutely right. So the y-intercept is where we cross the y-axis. And then actually on the topic of what things are, what on earth is a gradient? What on earth is that? Actually, let me move my chat a bit closer to where my camera is. Otherwise, I'm going to be looking over there this whole time. That's where my chat is. And I'm looking like this. That's where the chat is. So let me pop out the chat window, and I will. And yeah, it is perfect. It is absolutely right. It is indeed how steep the line is. Let me pop out chat so I can be a bit closer. Cool. Okie dokie. Yeah, it is indeed the steepness of the line. It's the difference between your line being like that and your line being like that, right? Very steep line, high gradients. Very shallow line, low gradients. Perfect, absolutely right. And with these two bits of information, with a gradient, with a y-intercept, you can draw any line. Any at all, any line. Because M will tell you how steep it is, and C will tell you whereabouts it is on the graph, right? Is it high up? Is it low down? Whereabouts is it in relation to the origin? And there we are. Moving on then, straight line graphs. On we go. Don't worry, I'll make the question a bit bigger in a second. Actually, I'll do that right now. Don't know why I'm saying in a second. This was a, where are we? Question 3 from an Edexcel paper. Remember, if you're doing AQA or OCR, it doesn't matter. They're all the same, to be honest. Very little differences, just some differences in like the way they ask questions and stuff, but not much difference at all, if I'm being completely honest with you. Not much difference at all. So if you're doing AQA or OCR, it don't matter. But there's the question then. So, June 2018, paper 2 higher, question 3. So quite early, would also be on the foundation paper as well. About question 24, 23, 22, one around there, mid-20s, early to mid-20s on the foundation paper. So the line L is shown on the grid. Find an equation for the line L. So as we can see, this is a slanted line that's going from bottom left to top right. Bottom left to top right. So we can start making our equation. We know it's going to have something to do with y equals mx plus c because it's a slanted line. Slanted straight line on a grid, right? That's what we know. So whether the gradient is positive or negative, I'm currently seeing in the chat, someone says negative, someone says positive. The way we figure that out is if the graph goes from bottom left to top right, it has a positive gradient. If the graph goes the other way, like this graph, I'm going to put in red for example, if the graph goes this way from top left to bottom right, it's okay, don't worry, don't worry about it, just because other people always make that mistake as well. I always find people making that same mistake, do not worry. If it goes from top left to bottom right, that has a negative gradient always. So if you see this, so what I sometimes do is, as soon as you see that it has a negative gradient, just put that in first so you don't forget it, right? I then do y equals minus, leave a gap, x plus, then leave a gap, right? Or minus, maybe don't put a sign, it could be minus, we don't know. And leave a gap after that point, because then at least you've got this in, so you're less likely to forget about it. Because if people put it last, people tend to forget about it. I see it all the time, right? So yeah, don't worry, it's a very easy mistake to make. So there we are, okie dokie. So then what we do is, what I always start with is the y-intercept. That's a bit easier, right? Everyone can see the y-intercept where it crosses the y-axis. Y-axis is the one that like goes upwards, one that reaches the sky and the floor. So this one here, where it crosses the y-axis is at this point here, which is minus 6. So we're going to have then y equals something something minus 6. Minus because it's a negative, and then 6 is the intercept. And there we are. Then what we do is to find the gradients, we draw a bit of a triangle. No, it's hard to do because you guys don't have the screen. You kind of imagine along with me, right? So what we do is we draw a bit of a triangle. Any points will do. You just want to make sure they fit nicely. So like this one here is quite nice. And then this one here is also quite nice. So you're finding 2 points that like where it fits, so it crosses exactly, right? It crosses like an intersect between like 2 boxes or 4 boxes, I should say, right? So you don't want one that's like here, right? That's like in some random miscellaneous place along this line. So you don't want like it to be here, you want it to be like here, right? And then you do, yeah, as Raheem said, yeah, I think that's how you pronounce your name, change in y over change in x, and that is absolutely right. You do change in y, which is this one here, which is 3, divided by change in x, which in this case is this one, just one here, which is 1. So it's 3 divided by 1, which is just 3. So you get y equals 3 is then the gradient, x, because that's always there, Riham, There you go, grand. I used to have a friend called Raheem, so I always, every time I see a name that's like somewhat familiar, I just go with him. I'm like, oh, that's his name. So yeah, apologies if I pronounce anyone's name. I'm rubbish at pronouncing names. Classic teacher there, rubbish at pronouncing names. But there we are, and that is that. Y equals 3x minus 6. Ta-da! And there we are. Do we have any questions? Any concerns? Anything that's like, this is not what I'm used to. I don't like this. I wish to clarify something. Anything. Like, yeah, you can do that, yeah, Rahaf? Yeah, I mean, you can, yeah. There is other things to do. There is other ways you can do it. You can just kind of look at it and think, okay, like 2 and then 1 and then that's that. Or you can pick coordinates. You could do like the coordinate, what is that, 2, 0, and then what is this, 1 minus 3, and then do like y1, or y2 take y1. y2 take y1 over x2 take x1. Even longer than what I did, but that would also work. This would be about 2 marks. I have about 2. You get 1 for the gradient and 1 for the full equation, because y-intercept doesn't really get you anything, because it's like easy, right? Easy being quotation marks. But yeah, 2 marks will be this question. Cool, and there we are. Let us continue forthwith. What about this guy? Let me make him a bit bigger so you can see him properly. This is an AQA question here, so those are in AQA. This one's for you. But again, if you're in Excel or OCR, it's all the same stuff, do not worry. So June 17, paper 2, AQA. So this question shows the cost of some taxi journeys. Okay, work out a formula for C in terms of N. A little bit different here, huh? A little bit different. Now you guys have a little ponder for a second, a little thinkaroo. Have a little think. What are we reckoning? Oh, not as nice cold. What was the question? Work out a formula. So this is the question here. Can you see it all? Or is part of it chopped off? Hopefully not. The graph shows the cost of some taxi journeys. Work out a formula for C in terms of N. Written down here. 3 marks for this one. It's not as simple as just like the equation of a line. It's got a bit more, got some context to it, right? They've thrown a bit of context in here. Instead of making it a bit simple, they've thrown in some context. So there we are. That's okay. That's all right. So let you have a little think, little ponder. It's getting warm in here. Fair, I've got this big turtleneck on, haven't I? Won't help. What are we thinking? Not sure? That's all right. No problemo. That's all right. Give you a clue. It's essentially just the equation of a line again, but because they've made this the y-axis C and the x-axis N, then your equation of a line has kind of been morphed into something else. Because normally it's this here, isn't it? Normally it's y equals mx plus c. There. But in this case, they've made the y-axis into like the c-axis, kinda. And they've made the x-axis into this like n-axis here for the number of miles. So then it'd be mn plus c. And then that's exactly what they wanted. I work out a formula for c. So this is for c in terms of n. There's an n in it. And there we are. Essentially, it's just the equation of a line, just with a bit of context sprinkled in. Right? Bit of context. So, I've got some good answers in here. Some very good answers. Let's have a little look then. So let's start with the y-intercept, as I always do, because that's the simplest bit. Y-intercept is where it crosses the y-axis, which in this case is like the c-axis, right? Because that's where the cost is, but the one that goes up and down. Always one that goes up and down. And that's going to be this point here, which is in this case 2.5. So then I'm going to get c is equal to, so cost is equal to mn plus 2.5. Have that as 2.5, 5 over 2, whatever you fancy, as long as it's right. Yeah, and then gradient time. So Gradient's a bit more awkward in this case. It doesn't really have many spots, so it works nicely. This one's a good one, as is, I think that one's really the only one here, isn't it? So let's draw a bit of a triangle so we can see and a good look at what's going on here. So we've got this going on there, and we've got this going on here. Okie dokie then. So let's have a look. So each one of these boxes in this case is a half. Right, so be careful with getting tripped up with that. Happens all the time. They'll make these boxes bound for anything other than one normally, because one would be the easiest. But they like to be awkward. So then we've got a half, 1, 1.5, 2, 2.5, 3. I think that's right. 1.5, a half, 1, 1.5, 2, 2.5, 3. Yes, indeed. So that there is 3. 6 boxes. But because they're all a half, it's going to be 3. And then this one has, let's have a look. Oh, these ones do go up in ones. That's nice. 1, 2, 3, 4, 5. And there we are. Then we have change in y divided by change in x. So the uppity one divided by the lefty-righty one, which is then going to be c equals 3/5 n plus 2.5. And that would be your final answer. And there we are. So be careful everyone's saying 6/5. They've done that on purpose. They do that on purpose. You're always going to be really, really, really careful with what they've put on their axis. Because often they'll do anything other than 1. Because they'll know that you will gravitate towards 1. Right? You'll think, oh, it's just one box. And they know that. So they do it on purpose. To be tricky. To be conniving snakes, right? They do it on purpose to trip people up because they're used to it being like, obviously in science you'll have it as well, where a box is always 1 because it's convenient. You'll have it in science, you'll have it in maths as well. So yeah, don't worry. A very common mistake. But 6/5, very common mistake. Remember, all these boxes are a half. I mean, you could change it to 0.6, but you don't need to. Doesn't matter. These are both proper numerical forms, right? It's like proper currency, you know. It doesn't really matter. It doesn't really matter. You could make this 5/2 and 3/5, but you could leave it at 3/5 plus 2.5. That'd be accepted. That'd be fine. Make it both decimals, both fractions. So fraction and decimal. Doesn't matter. Hasn't told which form to leave it in, so that's fine. Cool, grand. Any other questions before we shuffle onwards? Any remaining questions? But yeah, you can change it to 0.6 if you want, because 3/5 is indeed 0.6. But you can leave it as 3/5. Both. Kind of like legal tender. Doesn't really matter. You can pay in pounds and pence, so you can pay in pounds, or you can pay in pence. Doesn't really matter. Same thing. Cool. Okie dokie. Shuffling onwards. Bit more context happening here is an Edexcel paper. Could also technically be on a physics paper too. Kind of not really in this strict way, but could also be on a physics paper. Hello everyone that's joining, and I see a couple of people joining. Mikhail and Kelsey, thank you so much for joining us today for a bit of maths. So the next question. So I see Edexcel, November 2017, paper 2, higher. This one would also be on the foundation paper. Anything that's below question like 13 would also be on foundation paper. So if you do foundation, do not worry. It says the higher paper, but this is also on foundation paper. So, question 10. Here is a part of a distance-time graph for a car's journey. Distance against time graph, there we are, lovely jubbly. And then part A, between which 2 times does the car travel at its greatest speed? I wonder. Better physics as well, how fun. I like the overlaps between maths and physics. I like it when physics is in maths. Something familiar. Those who do physics. Perfect, Reba, looking good. Perfect. Rehan, perfect. Looking good. Absolutely right. Why is it that time? For those that have already answered, right, your fillers in. Why is it that time? Is it steepest? Grand. And why does that matter? Why does it matter how steep the line is? Why does that link with greatest speed? But why? Why does steepest gradient matter? Why are we looking for that here? Why am I not looking for the shallowest gradient? Or, I don't know, any other gradient? I mean, I know why, but for those who don't know, why are we looking for the steepest gradient? But why? Why do we care about steep gradients? Question to ponder. But why does a gradient link with speed specifically? Why does, in this case, the gradient link with speed? Because you are right, higher the gradient, higher the number, but why is it speed, of all things? Why not, I don't know, acceleration? Displacement? I don't know, using physicsy words. Momentum? I don't know. Why is it? Yeah, perfect. Yeah, Rihan's got it. It's indeed. Because distance divided by time is indeed speed for this equation here, as you guys probably know it as, which is speed. Where should I put this? Put it over here. Speed is distance over time, right? And we've got distance for gradients. We're dividing the y-axis, right? Dividing the y-axis, which in this case is distance, by the x-axis, which is time. So we're doing distance divided by time, which is indeed speed. So the highest gradient is the highest speed because the gradient in a distance time graph represents speed. And there we are. And that is indeed physics. I have to know that in physics as well. Physics paper 2. Paper 2 in forces, in like the car section. Actually, it depends actually. I tell a lie. That's AQA exam board. If you're doing EdXL, I think it's paper 1 for EdXL. Don't quote me on that. And then IGCSE, it's in both, I think. But don't quote me on the Excel stuff. IGCSE, I know it's in both papers, paper 1 and paper 2, if you're doing separates. But don't quote me on Excel. I think it's paper 1 though, although don't quote me. I think it's paper 2 for AQA. But anyway, moving on, getting beside the point. So there we are, yes, absolutely right. So it is indeed between 0 to 20 as gradients represents speed, and the gradient is the highest. If you can read my handwriting, it's not all that neat, but there we are. And then we want to work out this greatest speed. So can you please, if you can, and it's kind of a finicky ask with these lines, they don't photocopy very well, but what is the gradient going to be? Yeah, good luck with English Lit exam. I used to love English Lit. I was very good at it. I liked, I did, what did I do? Macbeth, Crucible, of Mice and Men, and another one, I think. Can't remember. But anyway, best of luck with English Lit. Can't help you much anymore. It was easier back in my day, because we got the book. Like in our exam, we got to just not take our own book, but we got a copy of the book in our exam, every exam. So you didn't have to learn any quotes back in my day. Learning quotes is, imagine, the hardest part of English Lit, because the quotes are long, aren't they? We used to just have to remember like page numbers, and we can just flick to the page and copy the quote down. We used to get book and play copies for every English Lit exam that we did. But anyway, and all the poems and stuff. But anyway, moving on. So yeah, I've seen one right answer, I believe. Let's have a look. So we've got, let's have a look. So here will be 300. So then you've got, goes up in tens. So 300, 310, 20. Oh no, it doesn't. Goes up in, what is that? 1, 2, 3, 4, 5. Goes up in 20s. 20, 40, 60 is indeed. So distance is 360 over time, which is 20, which is 18. And there we are. Fun. Cool. Okay. Any questions about any of that? Well done to those who got it. Any questions about any of that? Doing creative writing? Grand. Is that the one where you get the picture? I remember last year's picture, and it was like awful. I remember that. I remember everyone kicking off about it. Like the kitchen that looked like it's like a member of the Hobbit, like a Hobbit's kitchen. I remember that. But anyway, moving on, guys, moving on. Let's continue onwards. We'll do one more like this of the straight line graphy stuff, and then we'll have a look at inequalities. I think that's like a good step up, good move on. So this one, I couldn't find one that was for straight lines. It does come up. Don't get me wrong. Normally things like quadratics and stuff though. But I thought we'd see one like here, just for, I don't know, to link it all together. Can we see that? Hopefully you can see it. Hopefully it looks good still. Cool. So, part A, for those still doing the maths. Part A, complete the table of values for y equals 4x minus 4. So we've got X values, we've got Y. Those who do EdXL will see this question all the time. Comes up like every year. They love this kind of stuff. They love this question. They love this stuff. It's their favourite thing in the entire world. It comes up all the time. AQA comes up quite a few times as well. AQA like more wordy questions though. They don't like questions this straightforward. They like to be complicated. Do AQA. If you do EdXL, they love this. They love this kind of stuff. So yeah, have a little go then. Can you please have a go at filling out that table for me? So the equation, if you can't see it, I'll write it above here. So it's, the table is as follows. Y equals 4x minus 4. And the values of a minus 2 to 3. Those are the values. So every value that's an integer between minus 2 and 3. That's the question. For those who are doing it. Yeah, don't worry about mocks. I mean, mocks are just a practice, right? The more papers you do, the easier it will become for the real thing. Because the last thing you want to do is like go to your GCSEs having done no practice and just kind of get like shell shock, right? You don't want that. You don't want that, right? So what you want to do is do as many kind of papers like in exam conditions as you can. Obviously, it'll be like going to the hall and do it in a big old massive way, but like practicing in your bedroom, right? Doing passive as under time conditions, throw your phone at the side of the room and do them in time conditions. That'll help massively with the pressure of it all, because obviously you'll have a lot more adrenaline on the day. You'll have a lot more drive on the day than you will do just like a random Tuesday in your bedroom, right? Random Monday in your bedroom, right? So what I would do is do that. Practice in exam conditions. So you get used to the in exam conditions section of it, like being stuck with a paper for an hour and a half, doing nothing else but the paper for an hour and a half, right? Being stuck there at your desk, cemented, right? I think that's the thing that scares a lot of people, is having to like go a full hour and a half. Like that's a long time, isn't it, for a lot of people? People don't have very long attention spans these days, do they? Because of TikTok. People don't have very long attention spans. So practicing just sitting on your own with your own thoughts with a maths paper for an hour and a half will help massively. But yeah, you'll get used to them. You'll do exams every year for like until you finish uni now. So now that they've started, they ain't gonna end. They'll just keep happening. You'll get used to them, right? They just keep happening from this point on. If you do obviously if you don't do A levels, then they won't. And if you don't do a degree, then also they won't. But if you plan to take like the conventional route of the GCSEs and A levels, then degree, it's gonna just happen every year until you're like 21. So you get used to it. Don't worry. But anyway, let's just continue on. So what we do here is we substitute. We substitute each of these numbers into our equation. So what I always do is I'd set my if it's a calculator paper, I would set my calculator up and I would have it so that I've got like a standard equation. So I've got 4, open bracket, I put in minus 2 for now, close bracket, minus 4. So then that'll find me the first answer, which was minus 12. And then I just go back, delete minus 2, and put in minus 1, and then minus 8, right? So I have to type it out every time. Very nice. Just go back, delete 0, minus 4, go back, delete 1, or you can just do it in your head. That's also a possibility. You can also just do that. But I make lots of mistakes, so I do not. And then 3, and then 8. So yeah, that's what I got. Let me double check with some people in the chat, make sure I've done it right. 12 minus 8 minus 4, 0, 4, 8. Cool. Grand. Okie dokie. And then from here, it's just a case of plotting coordinates. So all we need to do from here, just plot these coordinates. We've got minus 2, minus 12, which is going to be there. We have got minus 1, minus 8, which is there. We have got 0, minus 4, which is there. We've got 1, 0, which is there. We have got 2, 4, which is there. We've got 3, 8, which is there. If one of your points, you're noticing one of your points like up here or something, right? You got most of your points, one of these is like way off where all the other ones are. You've done that point wrong. Go back and double check it. It's quite a nice question to make sure you're doing it right, because if all your points look good, then chances are you've done it right. Because they've chosen these equations on purpose because they look nice, right? So there we are. They won't have you join something janky or anything. So yeah, there we are. 2 marks. 2 for the table, 2 for the graph. Easy peasy, right? Easy peasy. These would be like 4 marks in the paper. Well, actually, yeah. There's 4 marks here. Also 4 marks in the paper. Yeah, easy peasy. Ta-da! There we are. Any questions about any of that? Dumb question involves you must have spoken out? Yeah, they do. Pretty much every question. The ones that are like 1 and 2 marks, they don't. But yeah, pretty much every question will do questions for working out. Because they have something called what's it called? The technical term for it. A positive marking. I think that's what it's called. Positive marking. Where they will opt to give you the marks rather than not give you the marks if they're unsure of what you said. If they're very unsure as to what you said, they will enforce something called positive marking, where they'll kind of give you the benefit of the doubt, right? Not for everything. Some things, if they can tell you're kind of trying to be cheeky with it, like say if you're like, say a key example I always use is in physics, where you got fission and you got fusion, right? 2 words that are very similar, and if they've asked you like which is which, like a question like which is this one, and you kind of mess up the writing of the handwriting, so it looks a bit like fission and a bit like fusion, then they won't give it to you, because that's kind of like cheating, right? You don't know the answer, so you just kind of trying to manipulate them, manipulate your writing to make it look like both, right? So that they won't give it to you, but then they enforce kind of like positive marking, where if you said something a bit silly, at some point in your working, they'll still give you the marks, unless it's like completely, absolutely wrong. Like they'll give you we'll give you the marks for the wrong bit. For the right bit, they will give you the marks. If you have something like contradictory later, essentially. Hope that makes sense. Cool. Okay, moving on. Let us continue. Let us see what else we've got. We'll do these ones in a bit. We'll see how long we have left after we've done inequalities, and then we might go back and do this in a second. So, inequalities on graph. This is now exclusively higher paper. If you're on foundation, you can still tag along, because essentially the most part is just drawing graphs. That's the most part for this kind of topic. But it is higher only, really, this bit, for the most part. So bear that in mind if you're on foundation. But anyway, moving on. So, June 17, paper 3 for Edexcel. Again, Edexcel like this question as well. AQA less so, because it's quite straightforward. And AQA don't like straightforward. They like making it as confusing as possible. But here we are. Hasn't up on AQA once there. So, it's on there, just not commonly, essentially. Oop, let me get rid of this bar so I can make it a bit bigger. There we go. Cool. Okie dokie then. So, question 13 then on this paper. So, write down the 3 inequalities that define the shaded region. So, first thing you need to do for this is just essentially give me the equations of the lines. That is all. Equations of the lines are what I need currently. So, let me color code them so you can see them all a bit better. So, we've got this line here. That's the first one. We've also then got this one here in dark green. We've then also got this one here in like this magenta-y colour. There we are. So those are the 3 lines. So, what are their equations? Feel free to start anywhere. We've got yellow, we've got magenta, and we've got green. Yeah, perfect. We'll do inequality in a second. So yeah, I will neither confirm nor deny your inequality is correct. But this yellow line here is indeed y is minus 2. Oop, that's a line, not a pen. Y is minus 2. That's the first line. That's that one. That's this yellow one. Grand. What about the green one? I know. This dark greeny one here. What's his equation? I wonder. So we've got the yellowy one. What about the greeny one? That green guy there. What is his equation? That green line. What are we thinking for him? Can we see it enough, hopefully? Bit confusing, I think. That is a sound point there. That one here, in case you're wondering. That does meet at a nice corner. And that guy there. Also this guy here. Also meets at quite a nice corner. And it's quite hard to see, isn't it? Online. It's not easy. Not easy to see these things online. Too blurry? Yeah, I'll see if I can like zoom in a little bit. See if that helps. Let me try. We don't really need all this space down here. So I'll see if I can move it over a little bit. It's just the graph. We don't really need the whole question. Is that a bit better there? Hopefully. Should be. Fingers crossed. No, the lines are a bit thick. They won't be like this in your exam. It's just because it's been online. Try your best. And then, yeah, we've got y. This one is y is -2. And then, yeah, good. Cool. Grand. And then the greeny one. I've seen one right answer. Well done, Ariba. Absolutely right. Is indeed. So this greeny one here is indeed y equals x. Because it passes through the origin, so there's no plus c, because it passes through the origin, and it goes one along, one up, one along, one up, one along, one up, every time. So it gets y equals x, and then we've got this purpley line here. So when you're filling out the equation, y equals mx plus c, you find a gradient and a y-intercept. Perfect, Tuba. Looking very good. Although you've forgotten one bit of it. But other than that, yeah, there you go. Immediately corrections. It's asking for inequalities, but I would do equations first. That's what I'd always do. Because the equations get you a mark. So if you write the equation correctly, then incorrectly put in the inequality, you can still get the method marks. So I would always write out your equations first, and then convert those to inequalities. That's what I would always do. So it is asking for inequalities. You are right, Rahaf. But I would do equations first to guarantee those marks, and then inequalities second. Because inequalities are the hardest bit. That's the harder bit. So I would do equations first, then inequalities second. Is what I would do. But grand. So we've got here, so we've got crossing at 1. So that's then y equals something something x plus 1. And then the gradient, it's going 1, 2 along and 1 up, which is 1 divided by 2, which is 1/2. So a half x plus 1. You're absolutely right. Cool. Okie dokie then. And now is time for inequalities. So what I always do with this is use my hands. Get my hands busy, right? What I do is I put my hands on the line. If then the shaded region, I don't know how to see it, if I put a hand on the line, if the shaded region is above the line, it'll be touching where the top of your hand is. If it's below the line, it'll be touching where your palm is. And that's something I use to figure out which way is which. That's for the slanted lines. Flat line is really different. So we'll start with the flat line. Y is equal to -2. So is our shaded region above the line or below the line? Is our shaded region above the line or below the line? What are we thinking? Is it above the line or below the line? Is indeed above. And if it's above, it's going to face y. Always. If it's above, it faces y. So above is going to be greater than, and then because it's a solid line, equal to -2. And there we have it. Ta-da! Is that what everyone else got? How are we feeling about that? Does that all make sense? Y is greater than or equal to -2. It's above the line, so it's facing the y. Then, moving on, let's do this green one. Might as well. If I use my hands, plonk it on there, the shaded region is on my side where my hand is up here, right? That's where I'm putting it over here where it is. That's on my second monitor. And it's over here where my top of my hand is. Therefore, it's going to be above the line. But it's also going to face the y, greater than or equal to x. And then a pink line, I'm going to put my hand on it again. And in this case, what's going to happen is it's going to be touching my palm, right? The shaded region is now touching my palm. If I put my hands and have it following along that pink line, the shaded region will be touching my palm. It's going to face away from the y, so it's smaller than. I'm going to get y is then less than or equal to a half x plus 1. And those then will be your 3 inequalities. And that is that. That'd be 3 marks, I believe. Let's have a look. Yeah. Oh, hang on. I see what's happened. 4 marks. There you have it. So you get 3 for the correct equations and then 1 for putting all the inequality signs in. That's what you get. So yeah, there you go. Fun times. How good is that? So yeah, that's what I would do. If you find all the equations of all the lines and then have a go at the inequalities. That's the tricky part. But I would always use your little like hands trick, depending on which way around the graph goes. If it's touching the top of your hand, it's going to be facing towards the y. Touching the bottom of your hand, be facing away from the y. And there we are. Cool. Any questions about any of that? Are we all in agreement? Are we all happy with what's happening here? Are we all happy? Hopefully. So if you can hear that, someone's like having a party or something. If you can hear that. Someone's like having a party outside or upstairs or something like that. You're happy? Cool, everyone's happy. Samuel, I believe, Samuel is here, has put something in the chat. Feel free, to... I thought it was the the one with the feedback. If you want to bring your friends along, I'm not going to say no to more people, am I? So, I thought it was a feedback one. That's kind of cringe me mentioning now. If you want to bring more friends, bring them all. All the friends can come. I don't mind. Anyway, next one then. November. Actually, no, we won't do this one yet. We'll do this one. This one, November 2017, paper 3 from AQA this time. The one and only time this has come up in AQA. You might painted a fly? Oh, typical. Snake. Maybe not. I don't know. But there we are. Moving on. Cringe, Olivia. Cringe. Moving on. So, question 23. Joe draws this graph to identify the region R represented by these 3 equations. Make 2 criticisms of this graph. Okie dokie. What has Joe done wrong? Joe's been silly. What has he done wrong? Can we spot it? What has Joe done wrong? It's been a silly goose, but how? What has he done wrong? Let you have a little look. Gradient for the dotted line is wrong. Let's have a little look. Yeah, you're absolutely right. Perfect. Actually, is it? Let's have a look. Hang on. So he's gone 3. Hang on. He's gone 1 that way and 1 that way. Are you sure? I don't think so. Freya? Maybe I'm wrong. Maybe I just can't see it. People can correct me if I am wrong. Again, as I said earlier, very silly mistakes is what I always make. Let's have a look then. So what else have people have said? First inequality is equal to. Is that an equal to sign? Yes, it is. Yeah, sorry, yes, it is. It is indeed an equal to sign. So these are called the inequalities. A y less than or equal to x plus 2. Y is greater than 3 minus x. And x is less than 3. Those are the 3 inequalities. Oop, can't really see the last one. X is less than 3. Those are the 3 inequalities that they've got here. Those are the 3. There we go. So what are we thinking? It is something to do with us. You're very right. It is something to do with us. In particular. Not sure. That's okay. It's something to do with the signs. That's your clue. Something to do with the signs. That's one of them. The other one is to do with whether it's above or below. That's second clue. Second mistake. Second criticism. So, if it's a less than or equal to sign, so if it's one of these signs, what kind of line is it? Is it dashed or is it straight? You tell me. You have to do the hand thing. You can do. One of these lines has done the hand thing wrong. Let's have a little think. But yeah, you don't have to use a hand thing. It's just a case of like helping in case you struggle spotting it. Like I used to always struggle spotting it. That actually kind of helps to like, because then it's always consistent. You use your hand and it's easy to see. Okay, is it high? Well, is it more than or less than? Because then it's just which part of your hand it is. Always consistent, right? Just a bit of consistency in case you're looking for that, or you can just see it. People can just see it, right? People don't need it. It's up to you whether you need it or not. But yeah, it's just a case of, it's like Fleming's left hand rule, right? Sometimes you need that, and then you can just see, oh, I know this pattern. I know this is going to lead to this result, right? It's a case of that. Some people need it, some people don't. Same thing. Okie dokie then. So, what I'm spotting first is that this inequality sign here, this less than sign, there's only one less than sign, but there's two solid lines. That's not good, is it? Only one dotted line, only one dashed line, but two ones that should have a dashed line. That's one criticism we could make, right? So which one is wrong? So let's have a little look-see. So we've got this one, y equals 3 minus x. That's right. That sign's correct. X equals 3. That one, actually, hang on. Yeah, that one's right. X minus 3, that one is not correct. So that's what needs to change. That makes sense? So the x is less than 3 should be x less than or equal to 3. There we are. Or it should be a dashed line, or should be a dashed line. Does that make sense? The solid line is for signs like this, where they have a line underneath them. If they have a line underneath them, not correct. Hope that'll make sense. And then let's have a little look, see what else is wrong. Let's have a little look. I'm seeing that this y equals 3 minus x wrong is incorrect, because they've got it as being that y is greater than, but greater than will be up here, right? And it's not. The shaded region is down here, right? It's below the line. So y is greater than 3 minus x should be y is less than 3 minus x. That would then be right. Ta-da! That was a tricky one. It's hard to see, in fairness to all you guys. It's hard to see online because it's, you know, it's easy to see in person in front of you, right? On a YouTube screen, it's not all that easy. I'm aware. Do not worry. I'm aware. It's not all that easy. But how do we feel about that? Now that I've said the criticisms, do they make sense? Also, feel free to correct me if I'm wrong. Maybe. It makes very silly errors with these kind of things sometimes. So if I am wrong, let me know. But how are we feeling about this thus far? How are we feeling? Feeling good, yeah? Reham? Feeling good? Good. Cool. Okie dokie then. Good. There we are. Okay then. Shall we do another one? Let's do another one. Let's do one more. You know what? Let's do one more. Let's do this guy. One more. Actually, I kind of want to show you a bit of a trick for this one, because obviously it's harder for you guys to do it because you don't have grid paper, so you can't really do this one properly, you know? You don't have any grid paper. But I can show you a couple of like tips and tricks for it. I suppose 10 more. I don't have time for that, unfortunately. I wish. Maybe one day I'll have my own stream and I can do all the questions you like. But unfortunately today is not that day. I have to do more work at whenever. My next lesson is at 7. So I've got places to be today. Places to be. But anyway, question 14 then, on an Excel paper. On the grid, shade the region that satisfies all these inequalities. Yeah, don't worry. I know you're joking. I was also joking as well. So don't worry. Got deep-hooded sarcasm. But on the grid, shade the region that satisfies all these inequalities. Y greater than 1, x plus y less than 5, and y is greater than 2x. Okie dokie then. So, what you could do to draw these lines, this one's a bit easy, right? This is just y equals 1. That's just this line here, right? Y equals 1. Ooh, so daisy. It's just that line there, right? Easy peasy. That one we can do, right? That one's nice. We like that one. For the others, you may have been taught to draw a table like what we saw. Where is it? Here, right? You might have been taught to draw a table and then plot your line based off of what you get from the table, right? To make your own little table, plot your points based on that. Who was taught to do that? To draw a little table. Was anyone taught to do that? When there was no table given to you to draw a line, were you taught to draw a table? That's what I'm asking. Or if there's a table given to you, then use the table. Might as well. Easy marks, right? Was that what you were taught? Yeah? You were taught that? So, you can do that. That works. So, there is a bit of a quicker way to do it. Yeah, there's a bit of a quicker way to do it. Because the tables are well and good, but there's a bit of a quicker way, right? I'll show you how it works first off for this one. This is more like a conventional one, right? This line here. This one's a bit quirky, but I'll show you this one. So what I do for this is I first find the y-intercept. That's what I always do. For any line, I find the y-intercept. That's going to be 0 for this one, right? Because it's got nothing next to it. So that's 0. Then what I do, instead of doing the table, what I instead do is just work on the fact that I know the gradient must be 2, right? So I know that for every change in 2 on the y, there must be a change of 1 on the x, or 4 and 2, or whatever multiple of these numbers you have, right? It doesn't really matter. It's the simplest ratio, the simplest numbers that could have been to give you 2 as a gradient, right? So all I do is I then go 1 along for this 1 here, then 2 up for this 2 here, there. 1 along, 2 up, there. 1 along, 2 up, there. 1 along, 2 down, there. 1 along, 2 down, there. 1 along, 2 down, there. And then connect them. And that saves you a bunch of time. So you could do a table. Works well, works fine, right? But I think tables are a bit long. I think they're a bit tedious. I don't really like the tables very much. Obviously, if they're given to you, it's 3 marks. You might as well do it, right? You don't want to just like not do the table. You know, what's the point in that? But if there's no table, there's no marks for doing a table. So there's no marks for doing all this tedious work. So what I would do is just that, essentially. Start on wherever the intercept is, and then just work from whatever your gradient is, and go up across and up in that. I mean, it's not really, I won't say easy to make a mistake, because I mean, it's got to be a straight line, right? If you got 1 point that you're connecting up, you think, oh, this line suddenly has a jolt in it, and then carries on going up. Like, why does that happen? You know? So it's I guess, but then even with a table, it's very easy to make a mistake with a table, and you can like spot it when you're plotting your points. But then it's kind of the same level of able to make a mistake, you know, because either you're gonna make a mistake with your counting, or you're gonna make a mistake with your counting, right? It's the same kind of thing. So this is what I do. I think it's a bit easier. So say if I was plotting the line, let's do a different one. Say if I was plotting the line y, that's my line too. Y equals, I don't know, 2x. Actually, let's do a different gradient. Let's do x plus 4. I don't know. Say I was drawing that line, right? What I would do is I would start with my y-intercept, which is 4, which is there. Then I know it's a gradient of 1. So I'm going to be going 1 along and 1 up. So 1 along, 1 up, 1 along, 1 up, 1 along, 1 down, 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 1 along, 1 down. And that would then be my line. So obviously it's not in the question to show you an example, but it's a bit quicker, right? Getting that speed going, right? And once you kind of get started, it's just a rhythm. It's always the same jump, right? So you're plugging into a number into the same equation over and over and over and over again, which just gets really tedious and annoying. So it's just a bit simpler, that's all. But anyway, moving on. And then we also have x plus y equals 5. So you could take the x over there, get y is less than minus x plus 5. That you could do. Or you could put it like this. I'll show you both ways. If you took this over, which I think you're probably taught to do, you then start at 5, which is there. And then gradient of -1, so we know it's going to go this way, but it's still 1, so it's still 1 along, 1 up. So 1 along, 1 up. You're just essentially making sure that your gradient is going the right way. 1 along, 1 down, 1 along, 1 down, 1 along, 1 down. And that with that line there. So a little bit quicker. And there we are. And that's that. That'd be that equation there. Or you could just plot it as it is, technically, I guess. X plus y equals 5. It's just all your x coordinates plus all your y coordinates makes 5. So you're going to have like 5 plus nothing, which is there. And then 4 plus 1, which is there. 3 plus 2, which is here. 3 and 2. 2 and 2. 4 and 1. And then it carries on in the same way as we've just seen. Like that. And 6 and minus 1. And then 5 and 0. And then 6 and minus 1 again. Like that. And that'd be that line there. Ta-da! Technically all these should be dashed lines, but alas. Actually, let me do that before I forget, as I'm going to forget. Let me do that, hang on. Where's my dashed line? Oh, there it is. So I don't forget, because otherwise I will. And then let me get my pen, my red one out again, then get my dashed line out again. And there we are. And then, that one should also be dashed as well. It's just a bit of a top tip for you, because I know everyone gets taught to draw that table, and I just hate the table. I have a vitrified hatred of that table, because people are smart enough to be able to do it without the table, right? I see so many very, very, very clever students get stuck into this rut of what they've been taught. Like, they know, like, they can, like, once they see it, it's obvious what the better way is. It's just a case of, like, trusting yourself to be able to branch out a little bit, right? And that's the lines. There we are. Cool, and then we have y has to be greater than 1, so everything that's less than 1 gets shaded, which makes sense, because if it's greater than, we don't want anything below that, so we're going to get rid of all that. We're going to get rid of all of this. Oopsie daisy, uh-oh, not that. Get rid of all of this, there we are. And then, for the, where are we, the red one, here we are, and that is y is then greater than 2x, put my hand on, y is greater than, so it's going to be everything above the line, so we're going to shade everything below it, which is this region down here. It's giving me doubts here. Actually, no, I think it is this region here. I think it's something to do a trick question, because they make you think it's going to be this little triangle here, but sometimes it's not. It might be this big old section here. And then we've got the green bit. Where are we? So then, where is that? Let's do that. So y is less than minus x plus 5. So then y is less than, so everything above it. So yeah, is everything up here. So then r